Because basically, the implication of what he's saying is that up until now, atheism was phony, could not be justified scientifically. But now, thanks to the latest, now in the year 2010, thanks to the latest theories, yes, you can be an atheistic thinker, but now we're going to say before that, you were not just, well, isn't that funny? I think there were hundreds and thousands of atheistic thinkers before this year who claimed they were pretty sure there was no God or anything. Anyway, this is the first part of the cosmological argument, origins. Now the second part I want to talk about is to do with laws, the laws of physics. The extremely complex laws of physics. They are so complex, there are so many of them, they interact in such an unbelievably sophisticated manner that every time that some scientist is able to understand, to discover some new law or some new interaction between different laws, we give them Nobel Prizes and honors and money and all kinds of things, okay? So that complex they are. We call them laws because they seem to have been decreed, so to say, by a ruler. I mean, when you describe a law of physics, you pretty much say something like, you know, when X happens, then Y and Z and D will also happen, and in connection with this reaction, then Z and B and D, you know, and you don't ask why. There doesn't seem to be any rational reason. Oh, well, we understand this has to be this. No, it's like this is the way it is. And when you study physics, you learn what the laws are, right? And you just know they act that way, and you don't ask why. I mean, why should a bigger matter attract a smaller matter? The law of gravity. Well, that's the way it is. And if you want to do physics, you better learn that law, and that's that, okay? Well, here's the thing. All of those laws, in their extreme complexity, in their unbelievable complexity, all of them must have been fully in place, fully at work, at the very first split of the Big Bang. At the very first split of a second, of the Big Bang. Or the Big Bang could not have happened. Does that make sense? All of the laws that regulate speed and light and heat and everything must have been fully in place right at the very first instant of the Big Bang, or we wouldn't be here today. The universe wouldn't exist. So now we have two problems. This huge rock we call the universe creates itself, as Stephen Hawking says, pops out of nothingness, and not only that, but even before it is born, it has figured out all of the laws it needs to proceed into existence. That seems to me a major problem too, right? Now let me say a couple of things about the idea of the Big Bang. The Big Bang was discovered in the early 20th century, early to mid 20th century. The person who discovered the Big Bang was called Georges Lemaitre. Georges Lemaitre. You can search that in Google if you want. Georges Lemaitre. And he was a physicist. He was a prestigious physicist in his own right from Belgium. And of all things, he happened to be, besides a scientist and a physicist, guess what? A Catholic priest. He was a religious person. He was a Catholic priest. And when he came up with this theory, some people didn't like it at all. Particularly one person called Alfred Hoyle. Fred Hoyle, a British professor of mathematics and statistics at Cambridge University, a radical militant atheist and a Darwinian evolutionary thinker. He didn't like it at all. You know why? Because this theory was so good, so convenient for religion. Because, of course, it said the universe didn't exist at one point, and then out of nothingness, you need a creator, if you say that. How convenient for religion. And who's proposing this theory? Nothing more, nothing less than a Catholic priest, of course. It's too good, right?
Doesn't it make it inconvenient for religion because the Big Bang Theory kind of goes against the theory of religion?
No, it doesn't. Let me get to your point in a minute, okay? I'll get to your point. So it was seen as really convenient for religion, really good for religion. And this upset Alfred Hoyle so much that whenever he lectured on these matters, he would make fun of the new theory by calling it the Big Bang. Have you guys heard of this Big Bang theory that this Catholic priest is talking about? Ha, ha, ha. Well, later he had to swallow his words. And it came to be called the Big Bang theory after this mocking name. The Big Bang really is a mocking name for the theory, coined by Alfred Hoyle, okay? Now, the funny thing, and with this I'm actually answering her question, is that today, particularly in this country, because this country is something special for these matters, you have these two groups, the fundamentalists and the Big Bang people. And so the Big Bang people are like the progressive, atheistic, Darwinian, evolutionary, and those, these fundamentalist religious people who think God created the world as it is 4,000 years ago, they're crazy. Well, this is such a crazy thing. I mean, the Big Bang was originally attacked precisely by atheistic thinkers because it was so good for religion. What do you think the Pope did when this Catholic priest came up with this theory? Do you think he chastised the priest? Do you think he censored him? No. He gave him a great award. He gave him an award, a public award. Hey, this is a great discovery. Because the Big Bang theory really is perfect for religion, whether you like it or not, it is. So when you see now this other side, this atheistic people like flipping this fundamental, look, Big Bang, Big Bang. I mean, Big Bang is essentially a great theory for religion. But of course, these fundamentalist people who think the world was created like it is 4,000 years ago, well, they've gone so far to the other side that, of course, anything you say is going to be an offense to them. But no, the Big Bang was really attacked precisely because it was so good to religion. It basically says there was nothing, and out of nothing, the universe appeared, and that, by the force of reason, requires a creator. So, Big Bang, the laws of physics, and now let me go to the third part of the argument, which has to do with evolution. Evolution. Now, when I talk about evolution, you may think, well, that's the weakest part of the argument, because we know that there has been evolution and everything has been explained, and we have evolved out of the apes. We're kind of relatives from the chimpanzees, cousins from the chimpanzees, and all that. And so we're not very amazed that we are like we are, because we know there has been an evolution. Well. Let me tell you, that requires more of an explanation than you might think. Yes, there has been evolution. But the way evolution has proceeded, as I said, may require more of an explanation than we get. And let me explain this in detail, okay? The original version of the Darwinian evolutionary theory can be summarized in this principle, the survival of the fittest, a principle which really was taken from the world of economics, but then it was actually appropriated by Darwin himself. Now, we know today that that is not enough to explain the evolutionary process, that the survival of the fittest, as it was believed for about 50 years, is not a sufficient principle to explain evolution how it's happened, even with all of the other additional explanations that Darwin included. We need something more profound, in a sense, in the theory, and that came with what is called random genetic mutation, random genetic mutation. What that means is, in our gene pool, some genes will mutate over time. Those mutations will stay within the group, and at some point, when the environment changes, the conditions in the environment change, it may turn out that those mutations, which were irrelevant for a long time, are helpful. They may help us survive. And then the individuals that possess that mutation will survive and procreate, while those other individuals of the group that do not possess that mutation will perish. So that will, in a sense, move the species in a direction. Then another mutation will occur that may be one day again essential for survival, and that will keep moving the species in a certain direction till we end up being what we are now, okay? With our hands and our head and our eyes and our body and nature as it is, with all its incredible complexity and diversity. Yes, let me give you an example that evolutionary thinkers usually give. There's a moth in England, a moth, a little butterfly, that up until the 19th century came in two varieties, so to say. There were white moth and a black moth. So the color, the difference in color, was due to a genetic mutation within the species. And both of them survived, but 50% were black, 50% were white. It's just the mutation was at that point indifferent. But then with the Industrial Revolution and pollution ensued, if you've been to England, you may have seen that many brick buildings are blackened, really dark through pollution. And so the whole of England became really, the buildings, especially in the large cities, became blackened. Okay? And then what happened was that the white moths now, by contrast with the black of the bricks and the buildings, became easier to spot by their predators, by the birds that eat that kind of moth. While the black moths were able to hide better in the black background of the buildings. And therefore, the black moths survived and turned the whole species, pretty much almost the whole species now is black, while the white moths disappeared because being white didn't help the survival. They were actually being eliminated, while the black ones are the ones that survive. Well, there you have an example of how random genetic mutation may help adaptation to the environment and therefore lead the species in a certain direction. Now, you need to apply that principle of random genetic mutations happening and then accumulating on top of each other over hundreds, millions of years to give rise by this random process, essentially random process, to what we are now. So you may think that that process may have helped or may be partially explanatory, but if you think it fully explains how we have come to be how we are, then you really have to explain a lot of coincidences, truly unbelievable, statistically difficult coincidences in which certain mutations accumulate on top of others, associate with other mutations. For example, to give rise to the human eye, there are huge problems when you try to explain that from an evolutionary perspective, because there are some complementary mechanisms in the eye, which means that one of those mechanisms doesn't make sense without the other that complements it. But when you look at it from an evolutionary perspective, you need to posit the appearance of one of those mechanisms first by itself, which doesn't appear to make any sense.